example about the possibility to jam a system if it is defective or not. So we have a 10 station inline assembly machine. Here's an ideal cycle time of 6 seconds. The base part is automatically loaded prior to the fryer station, and components are added at each station. The fraction defective rate at each is Q equals 0.01. In this example, all Q are exactly the same. In this example, all value of Q are exactly the same. So let's do the pointer. So we have Q equals 0.01. And the probability that effect would jam the system equals 0.5. When a jam occurs, the average downtime is 2 minutes. Cost to operate the machine is $42 per hour. The costs are ignored. Determine average production rate of all assembly. Of all assembly, which is absolute per hour. How many assemblies per hour? So we have the TC, which is the cycle time, equals 6 seconds. 6 seconds, this is exactly equal to 0.1 minute. The average production cycle time is equal to TP equal 0.1, which is TC, plus how many stations we have? We have 10 stations, a 10 station line. Each one of them, we have a probability M 0.5 and then 0.01 times the value of 2. The value of 2 is a jamming time. So all the value will be equal to 0.2, which is the TP value. Since TC equals 0.1, so we need a value of TP 0.2 and TC equals 0.1. As a jamming time, it will be equal to 0.1 per unit. The production rate in this condition, so RP equal 60 divided by 0.2 is equal to 300 assembly per hour. So this is the first example. Meaning what? Like, since it jams the system, so we need to take into consideration another time on top of the cycle rate, and this must be taken into consideration in the process of the production rate. Yield of good assembly, so PAP is equal 1 minus Q plus M times Q power N, which is 10 station. Again, so the good assembly, if it jams the system, so we need to change it. If it's defective and jams the system, so definitely we're making sure it's being replaced by a good one and is not defective. Average production rate of good products, average production rate of good assembly is determined by the equation. So RAP is equal 300, which is RP, times PAP. So 300 RP times PAP value is equal to 285.3 good assembly per hour. The efficiency of the assembly machine, E is equal to 0.1, which is literally TC divided by TP. 0.1 divided by 0.2 is 50%. So, and the last one, cost per unit to operate the system. So if we consider the cost, if we go back to the cost, just to explain it really quick. So cost per unit per good assembly is equal to, let's enable the pen. So cost per unit is equal to CPC, is just cost per unit, is equal to CM, cost of material, plus operating cost of the assembly system, dollar per minute, times average production minute per unit, and plus CT, cost of disposable tooling, so how much tooling we're changing, which we're not consider in this example. Yield form is how much we're really yielding in the system. So if we're going to consider the average here, or cost per unit here, so CPC is equal, so $42 per hour to start with. $42 per hour is literally $42 per hour times how many minutes per unit? 0.2 minutes per unit. So this is $42 per hour. This value is equal to 0.7 divided by, so this would be in minute, times 0.2. As a fact, we consider 0.2 instead of 0.1 because we need to consider the jamming time. As the system is running, regardless of jamming, we have to consider how much it costs to run the system. So 0.7 is value times 0.2 minutes per unit. So the value is 0.147 per unit. So this is dollars per unit. Okay. Another example here. Let us examine how the performance measures, this example before, are affected by variation in Q and M. If M equals 0.5, determines the production rate, yield, and efficiency of the three levels. 0, 0.01, 0.02. Second, for Q equal. So what we did here, we considered several alternatives for Q, which is a jamming rate, and M, which is, Q is a defective rate, and M is a jamming rate. So if the defective rate is 0, how often does that jam the system? What would be the production rate, RP value, as we just did before, which is literally TP 60 over TP. What would be the yield value? The yield is a good one. Again, yield, let me re-explain it. So it's literally is 1 minus Q plus M times Q, depending if we have more than one station or not. The average production rate of good assembly is literally the production rate multiplied by the yield. So it's literally this one multiplied by this one. Okay, and E efficiency is TP over TC, or TC over TP. It's like how much jamming is taken from the system and how much time is required to do that system. Okay.